Hi, my name is Adam. I'm going to be demonstrating our Gang programmer on 8xST discovery kits. Here's the hardware setup that we're using. Now we've made slight modifications by replacing some of the SD cards, so there will be 3 different types of cards in total. A fast one that you see here. This one on the spec can perform up to 90 megabytes per second. And these will be boards 1 and 2. Now moving on will be boards 3 and 4. We'll have the default SD cards that come from ST, and these can write up to 10 megabytes per second. And then boards 5 to 8, we've replaced this with a medium performance card, and these on the spec can write up to 30 megabytes per second. So faster than the default ones, but not as fast as board 1 and 2. And here we're just showing all the boards. After that is done, we'll go over the software setup, which will be the files that we'll program, and then we'll run the auto program procedure that involves setting up the partitions on the SD card, erasing everything, writing, and verification. Okay, so that's the setup. Now let's go to the software. This is the TSV file that we're using, so we're going to be programming roughly 800 megabytes of data on the DK1 board, and we'll be doing all 8 boards in parallel. So we'll just clear any history that we had before, and we're going to start the auto program procedure. Now what this one will do is, first it initializes the boards with a fast bootloader that we designed, and then it's going to transition to programming the actual files. So now our fast USB driver is booting in, and we're starting the programming procedure. Now as you can see, all the boards are somewhat proceeding independently here. Now obviously the fastest boards 1 and 2 are ahead. Boards 3 and 4 are behind, and those are the original ones, the slower ones. And then we have boards 5 to 8 with the medium speed cards. At the end of programming, we will go over individual results to show the per target programming speed. After this test is done, we're going to compare the aggregate results, the results that we get by programming all the boards at once. We will compare those to the speeds that we can get by programming each board individually, and we will demonstrate that the programming speed that you see here on all the boards is the same as you would get if you program one board at a time. Okay, so after programming is done, the last step is verification. So as you can see, the faster boards have almost finished. With programming and verification, and the slower boards are finishing the last file and they proceed to verification. Now what you'll see here is that when we do get to verification, even on the slower SD cards, the verification will still proceed very quickly, because even if write speed in some cases can be slower, usually the read speed is very fast. So we'll see here that the verification even on the slow boards will be about the same speed. And that will be about 23 megabytes per second on the verification itself, even if, for example, write is much slower. And one more thing to point out here, the maximum performance actually on the DK1, DK2 boards is limited to high-speed SDIO mode, so we are not going to have, even for reads, anything more than 25 megabytes per second. And we'll see that even on the fastest cards, we'll see that due to overheads, the maximum write speed will be lower. However, on the second test, we will be looking at evaluation boards which can operate at a much faster DDR50 mode, and we'll see that the write performance there is much better. Okay, so the auto program procedure is finished. Now we're going to go over each of the individual results for each of the boards. So here on the fastest card we have a write speed of 16.81 megabytes per second and verification of 23 megabytes per second. Board number 2 should be similar performance, again about 16.77 and 23 megabytes verification speed. Now target 3, that's the original SD card, so here we have around 6.5 megabytes per second write speed and read of, again, the same. Board 3 and 4, similar results. And now to the medium performance card. We'll see slightly better than the default, but not as good as the fastest one, so 14 megabytes write speed, and again the same read speed, etc. Board 6, 7, and 8 will show the same performance. Now we will proceed with the individual tests. So what we're starting off here is the individual setup with 8 boards, which we're turning off except for board number 1. Same setup file, and physically reset board number 1 so that it starts with the default DFU driver. Now we'll proceed to auto program. Now this whole process will proceed the same as it did before, so we're just gonna speed it up here times 4. Just to go over the programming part quickly, and then we'll slow down once we get to the actual results. Okay, so here on target 1 we're seeing 16.75 megabytes per second writing speed there, which is the same as in the aggregate case, and 23 megabytes for verification. Now we're going to go over target 3, so same, reset, and programmed. So similarly here we're going to speed up to 4x speed just to get to the results. So this is the slowest board that we have, and this one before was showing roughly 6.7 megabytes per second. So we're going to see if we see the same performance, and indeed we do. 6.5 on the write, 23 on the verification. Okay, so now after this is done we're going to go to the last board 5, to the third group. Same thing, board was reset. We're starting with the fast bootloader, and we're going to speed up the programming to get to the results. And here we should see roughly 14 megabytes write, 23 read, so there we go, same results. So the point here is that regardless of whether we are programming 8 boards or whether we're programming 1 board, the performance is the same. We're going to follow up this demo with an evaluation of programming speed on a couple evaluation boards that we have, and they are much faster than these DK1 boards, so we should see some more stress testing on the individual unit tests that will show with the fast SD card and the fast eMMC memory, and this will be the next video. Bye.